the Roadshow by CNET's live stage at the North American International Auto Show here in Detroit. I'm Tim Stevens, editor-in-chief of Roadshow. Between here in Detroit and last week in Las Vegas, we've been hearing a lot about connected cars, but not a lot about when and how we're going to get them. Joining me now to discuss that are Paul Malhotra, Director of Connected Vehicles at Audi, Patrick Morgan, VP and GM of the ADAS product line at NXP, Roger Longto, Associate Director of Strategy Analytics, and Matt Smith, who's Intelligent Transportation Systems Manager at the Michigan DOT. Before we start talking, we've put together a short video that'll help level the playing field.
We live in a world where everything is connected. There are smart crock pots and smart thermostats and coffee makers, alarm clocks, even smarter frying pans. And yet, our cars still don't talk to each other. Sure, there are plenty of cars that you can start from your smartphone or even your smartwatch, but still, in 2017, we don't have a reliable way for one car to radio back down the road to another car and warn it about traffic or road conditions. The technology is called V2X, or vehicle to whatever communications. In the eyes of some, future cars will be able to talk to each other and to smart roads and smart traffic lights, always knowing exactly what's happening around them. But yet, over a decade after this tech was proposed, it still hasn't happened. And so, what is the state of V2X? Are we any closer to this ideal being a reality? Or have we gotten to the point where the industry has evolved and doesn't even need this anymore?
It turns out when I said a decade, I was actually a little bit cutting it short. Palm, how long have we been talking about V2X, and is it even V2X anymore? Is it V2E, V2I, V2
It's
what?
interesting. The first time that the ITS organization had proposed that spectrum be set aside for active safety-related applications for B2B communication was in 1997.
So 20 years now.
So it's been 20 years, yeah.
That's quite a while to be talking about a technology revolution for transportation.
It has been a long time, and I think that at the time there was also a lot of understanding that this, in order to achieve the kinds of communications that we were looking for, that you would need to have a standard that was based on something like an 802.11 type of technology. And so the DSRC standard was actually proposed because at the time, that was the fastest available. And if you looked at cellular at the time, cellular was analog. And so what has happened over the years, if you've started seeing more and more of the data applications now happen through cellular, and I think the dialogue now is more around what still needs to happen through DSRC and what can be achieved with cellular. And maybe we're looking at more of a harmonious combination of these two technologies working together. At Audi, we've actually looked at connected vehicles as a pie, and each sector of the pie is a domain that the connected vehicle actually touches. So we've been walking our journey from vehicle to destination, to vehicle to passenger, to so on. Vehicle to infrastructure we actually touched last year with the launch of a service called Traffic Light Information in Las Vegas. We will be rolling it out nationwide, but what this does is it uses LTE technology in the car, and the fact that some cities have already managed to centralize their traffic management systems and use the data from these centers, run them through smart algorithms in the cloud that use machine learning to create a forecast to advise the driver of when the light will actually turn green. So this has been quite an interesting way to see how you can use two different ecosystems that evolved independently, one on the city side, one on the car side, and bring them together in an intelligent way that makes sense to the driver as well.
And we're going to be talking a lot about ecosystems and different platforms. You touched on basically mobile wireless networks as well, which we'll get into a little bit because that's, I know, a bit of a hot topic, and I think we've got some differing opinions on that. Patrick, what are some of the big advantages of this technology? We talked a little bit about traffic lights there and other communications, but what sort of things can we expect from this sort of communication? What is the grand idea of having all this connectivity in our cars?
Yeah, it's a great question. I mean, what I think the question that we also ought to think about as drivers is, what is it that the benefit that's provided from a V2V technology compared to other technologies that are in the car? And let's also go back to what is the function of an autonomous driving vehicle. I mean, at the heart of it, the function of autonomous vehicle is to safely transport us from point A to point B. So what does V2V provide that the other sensors don't? Well, there's two aspects. The first is it provides an ability to see around corners or communicate with traffic lights or other cars or pedestrians. And secondly, it provides the ability to do this in near real time. So therefore, what are the benefits? Let me maybe walk through an example. Because it can provide near real time and ability to see around corners or even see around other objects or other cars, imagine a situation where you've got a line of cars on the highway driving at high speeds, and imagine a situation where perhaps one of the cars on the road needs to emergency brake due to some unforeseen event. Well, using V2V, the message can be sent from that car, received by another car that would be equipped with V2V, and then be able to take evasive action or perhaps emergency brake. And in that line of cars, the intention there obviously is to save lives and to take evasive action where, yeah, ultimately doing this safely and securely and saving lives.
It seems like, you know, an ideal situation, something that we would all want in our cars, and it's something we've been talking about 20 years. Roger, why is this taking so long? That's a very broad question, but are there some reasons why this has taken so long to get to the point where we got to talk about implementation?
Because the intention was to put it in large volume passenger vehicle segment, which means the standards are going to be much higher, the requirements in order to put it in there. That hasn't done anything to bring down the cost, because the cost is still going to be around $300. It is a little bit dumbfounding when you look at the mandate itself is solely for a "here I am" message being broadcast 10 times a second. Okay, the beauty of it is its simplicity. So cars announcing where they are, but of course, the car has to have that built into. You have to have that built into every car. So some of the applications, you know, Patrick could have referenced was, for example, so he was talking about automatic emergency braking. Maybe a car or two ahead, you can get notification of that car emergency braking without seeing that car. Although we are assuming reception of the message, which actually isn't mandated, and the applications aren't mandated, but they are very interesting applications. So for example, if I'm going down a 2-lane highway opposing traffic and I want to pass a car, I could get a notification telling me there's a car coming, you don't try to pass right now. Or I'm trying to make a left turn, don't try to turn in front of this car, you can't make it. Or the traffic light connection is an application that can be done with cellular and DSRC, or together actually, based on how close you are to that traffic light. So it's a compelling application, but the devil is in the details. So after 12 years, so 20 years the spectrum was set aside. For 12 years I'm familiar with the work that's been going on setting the standard and writing the code to support this. And there's still quite a bit of work to be done. And while we are within sight, because you were asking at the beginning, are we any closer? Of course we're closer, but there's a big obstacle to overcome aside from the various protocols of the National Highway Traffic Safety Administration. Security. Security wasn't such a obsession, I'd say 12, 20 years ago. Now the government is in the position of proposing to mandate an attack surface in the car. And depending on how we deliver the credential revocation list, whether we're going to do that over cellular or whether we're going to use Sirius XM, a satellite, to let vehicles know that there's a bad actor and to block that signal. It's a significant challenge to overcome, how we're going to communicate that information. Still to be determined. Also, infrastructure was not part of the mandate either. And some people look at it as mandating the creation of an entirely new network, which, as you might imagine, probably is going to cost a little bit of money.
Absolutely. Matt, can you talk a little bit about the infrastructure side of things? We talked about cars talking to each other, but there's definitely something of an expectation that the municipal governments will have a hand in this as well, with being able to transmit information to vehicles about lane status and that kind of thing. And that requires some investment on that end too, right?
It does require some investment, but it's still exciting about the potential that the technology has. When you look at obviously the vehicle-to-vehicle communications, and when you're driving down, crash rates is always huge, but there's a couple key applications from the infrastructure side that speaks to the same goals that most transportation agencies have, which is getting people, I think I heard mentioned here, safely from point A to point B. And there's a couple applications out there, one in particular that we see is DSRC based, others that can use a merging of different communications technologies that require some level of investment from the infrastructure side, but I think the benefits that we can receive from it rival putting money on and building and widening intersections and physically improving the geometrics of an intersection. If you look at something like the red light violation warning, and this type of application, you have the traffic signal broadcasts over DSRC, the traffic signal phasing and timing from the signal at 10 times per second. So equipped vehicles, like Roger mentioned, under that NHTSA mandate, vehicles are equipped to transmit, but conceivably, if we're broadcasting the information out, vehicles can also be equipped to, under the same same communications protocol, receive the information back, so it can receive the signal phasing and timing, receive, and in the vehicle, the application on board the vehicle can determine based on the vehicle's position and heading, hey, I'm going to be running this red light, and start broadcasting a warning to the driver. That to us is huge, because one of our biggest safety problems are red light crashes. And if we can start driving down those crashes with a minimal investment in infrastructure, that's big. There is some kind of investment in infrastructure. There is $300–400 per intersection minimum, depending on how modern your signal controller is. It could be upwards of $5,000–7,000 to equip a signalized intersection to be able to broadcast out this information. But still, when you look at what the alternatives are and what you're trying to do, it's an easy case to make from a benefit to cost ratio. But there's a big education component to it, to the public agency standpoint. It's not like there's going to be a big pot of money to deploy this kind of infrastructure and application support. It's going to be competing for money, the same money that's used to fill potholes or improve bridges. So it's an education component to it, where we need to educate our agencies about the benefits that we can see from this technology and invest likely.
I want to make one clarification with regard to the "Here I am" message. It's not there's no privacy violation implied in there. First of all, there's no data saved, and everything's anonymized anyway. So, extensive measures have been taken to ensure privacy is preserved.
Here I am, saying
it's not a data collection platform. So you were talking about data, et cetera. Not really implied here.
I think that you asked the question why it's taken so long. I think part of the reason is not just the maturation of the technology, but the business model, as you mentioned. If making this effective requires every car or most cars to have the technology, and to have every intersection or every part of the road to also have the technology, there's a major investment that needs to be made in putting that technology in. Now, I think that on the OEM side, we've seen a lot of efforts because of the growth of the connected vehicle space, where we've been able to build a commercial model for putting elements of that technology in the car already, to the point that if you needed to upgrade to the next level, it can be done very easily. What we haven't seen yet is the rollout on the infrastructure side on the same technology. And so what has happened instead is the cities have been working on connecting existing traffic infrastructure, for instance, traffic lights. And when we did our plans for the launch of the TLI service, we actually found that there's like three tiers of cities. There are cities that have had the benefit of taking a lot of the decisions over the years, where they've centralized their traffic management. They have a lot of the intersections already equipped with lights that are connected and centrally controlled, and they've kept the software all up to date. So for cities like that to switch over to a service such as the one we have in the Audi now, is actually a very minimal cost proposition. I think when we were having this discussion in Las Vegas at our launch, Tina Quigley, who's the head of the Regional Transportation Center in Southern Nevada, mentioned that it's $6 million to build a mile of asphalt. Versus they probably got this done with about 1,100 connected lights for probably less than the cost of an Audi. And so if you compare that, the return benefit to the city for doing that is, during the development phase, they've been receiving information from us, from our engineers, where they might be getting a strange signal that could be a result of a pedestrian button that was stuck. It could be a camera that is out. And this type of information would normally require investment in a lot of infrastructure on site in order to get that. And then over time, what you're able to do is provide quarterly information back to the city on traffic patterns, which can help them understand how to manage this. So a tier 1 city, for them a decision is very easy. A tier 2 city is where they do have connected traffic infrastructure, but they may not have kept all the softwares up to date, and so there is a little bit of investment that needs to go in there. But then there are some cities that don't have that hardware in place yet at all. And what do you do about those cities? And I think for those tier 3 cities, the decision really needs to come down to, are we going to follow the vehicle to cellular play and leverage that technology, or should we just invest in DSRC right now and use that as the platform? And I think that's an unanswered question at this point.
Well, Well, the federal government obviously has its thumb on the scale as to how they, but it's a pretty light thumb. It's not a very heavy thumb. There's not enough money to really push it through. But I'm surprised you didn't mention what the value proposition is to a city for the traffic light information service that you're offering, which is congestion reduction, greater fuel efficiency, and potentially even life-saving elements.
Absolutely, thank you. Yes. I thought my monologue was going on too long. I needed to stop at some
I'm
point.
sorry, emission reductions. I'm sorry, emission reductions.
Yes, I mean all of that, from the congestion, emission, safety standpoint, and then we've actually made a point of mentioning that if you actually observe people that are in these cars that are talking to the traffic lights, it's a different driving behavior. You're approaching a light and the system's telling you you're not going to make the light. So you might as well start slowing down. You put your foot off the accelerator, you kind of relax versus trying to make the intersection. I think that has some additional societal benefits overall. You were saying, Matt?
Good point that you brought up about what cities and municipalities and agencies can do to prepare. We hear that a lot. We've worked a lot with USDOT and OEMs on some DSRC infrastructure and DSRC-based applications, some cellular-based applications. When we hear back from our peers say, hey, what can we do to prepare for this V2X world? First impulse is like, well, I don't know, you have to wait and see, before you start committing a whole lot of money to any one technology. But really what the answer is that we really get down to is you can prepare for any kind of the communications technologies by making sure you have your infrastructure is communicating on the back end.
Right.
By you have your backhaul communication, whether that's fiber, cellular, the Vita Cloud type of scenario. You have the back end systems in place, again, whether it's your own or whether you're contracting out or you have a third party, and be sure that you have your staff. You're getting your staff up to speed on knowing how to operate in this new environment. You could go a long way, and then it doesn't matter if you're DSRC-based communications or cellular-based communications. You've got all the parts in place to start transmitting your information however you need. So that's a lot of that.
That's a great point. In fact, one of the things that we've realized is because the traffic agencies have never needed to send data real time to an external party, when they started doing it, it took a little while to get all the kinks removed. And so there were instances where the data wasn't always clean, or there were gaps in the data. And so that was, all the way from systems not being up to snuff to the fact that in office hours, the system is sharing it with people doing normal work. And so, those types of issues come up which you don't necessarily envision. But it does become part of the learning curve that needs to be crossed.
Yeah, I mean, the real-time aspect of it is one thing that really differentiates some of the early standards that are built around, for vehicle-to-vehicle communications. It's a really good point to make it. This emergency braking application is one, traffic light information another. Maybe that's also part of what makes the technology so exciting is that there's so many different applications, vehicle-to-vehicle, vehicle to obviously the infrastructure, obviously even to pedestrians and things as we start to think into the future. Obviously there's going to be a disruption of business models. Even things like autonomous trucking, like we saw in the demo earlier, could also be a very interesting application. Yeah.
What are the commercial implications of V2X transportation? Obviously, the safety considerations are very much the same, if not even more important, as we're talking a large rig carrying a lot of cargo. Are there other implications for commercial applications than there are for the consumer applications?
Definitely. So let's think about that. So first of all, on the screen, on the video, we saw the truck platooning demo with the DAF trucks. This was something that we participated in, and we were quite excited by it. The way that the truck platooning demonstration worked is basically the idea is that trucks follow each other in a line, very short distance in between them, and the idea is that as the lead truck makes driving decisions, that signal gets sent over to the trucks in the platoon, and they're able to act as essentially one vehicle, moving seamlessly. We were able to show that happened even with a guaranteed latency between the trucks that actually was faster than the fastest human is even able to react. And so this is also a really, really interesting type of application. Not only do you have benefits on things like efficiency, less drag and so forth in the convoy, but you also have benefits, obviously, of things like safety and some other types of applications.
The interesting part about what you're describing is you were able to do that without any infrastructure involved, right? So this is cars talking to cars. Right. And I remember way back in, I think, the 90s, there was demonstrations being done with magnets on the road and cars platooning based on that. And that was supposed to be the way of the future. But, obviously, we've now come to the point where technology has evolved to the point where you can use other ways for completely bypassing that investment.
I think a big turning point of that was back in the early part of the development of the DSRC standards, where the initial thought was, hey, we could get this to work if we have one of those DSRC radios at every intersection and every critical part across the country. Well, that worked out to be about 250, 300,000 DSRC locations at $20,000 a piece. It quickly became apparent, hey, how are public agencies going to pay for that? So let's start seeing, is there other V2V technology or something else that makes a lot more sense in the short term to pursue, and then the V2I benefits can start waterfalling from those V2I
Those are the figures I've heard, $300,000 and $20,000 per. But in Europe, they've taken a different approach with V2V. So they've pushed it more towards commercial vehicles and those kinds of enterprise applications. So you have Venium in the port of Porto in Portugal using V2V technology in trucks for logistics purposes, certainly for collision avoidance as well and safety, and platooning throughout Europe. They're building corridors for trucks. But enterprise applications make sense immediately. And we'd be having a very different conversation here today if all those guys who got together and women 20 years ago or 12 years ago said, hey, why don't we put this on emergency and service vehicles and commercial vehicles first? That would have been the quick path to market. That's where NHTSA had a mandate authority and could have fast-tracked things. If you're trying to put things into passenger vehicles, the protocols take much longer through NHTSA. They don't have the power to just snap their fingers and get this implemented.
And dealing with the cost, of course, no one wants to add that cost onto the product that they're selling to consumers. Are there standards in place for any things we're talking about, pontooning and things like that? Are there any standards in place for that sort of thing? You know, we have the DSRC standard for wireless communications from one vehicle to another. But is there anything as far as protocols for transmitting information about vehicle state that would enable something like pontooning?
So, I mean, there's, I'll start. I think, Roger, you probably have a lot more detail on this as well, but the SAE has a couple of standards that define the message set as well as some of the protocol level details. IEEE has some standards for how the actual network technology level operates on the 802.11 layer. So all of these come together, and I think from our standpoint, it's not so much about coming up with new standards, but intelligently using the standards that are already there. And again, I'll use an example from how we implemented the TLI system. The communication that's coming from our service provider to Audi in the vehicle over the LTE channel is actually talking the same language that is defined by the SAE J2735 standard. So essentially it's the same message set, it's using the same SPAT and MAP data sets, but we've trimmed it down to make it a little bit more efficient over a cellular technology, and also because some of these other messages were not really needed at that point. So the car is prepared to receive this information, and then the user interfaces, the intelligence that's being built in the car in terms of when do you show information to the customer, when do you not do it, what's the best way to do it, all of that can be done independently. And then whether or not the transport protocol is over cellular or it's coming over DSRC in the future doesn't really matter, because the car is going to receive it in the same language. It knows what to do with it. The other thing that I think that we do need to understand is the reason that we can actually see much further acceleration now with these technologies is we've sort of divided the world into the OEM world and the infrastructure world, and if they could only talk. I think what we're forgetting is you can connect this world and you can connect this world, but you need an intelligence layer in the middle, and whether that's in the cloud or in a data center somewhere, it's machine learning, it's algorithms that actually take the data that's coming in real time and have the supercomputing capacity to actually be able to build forecasting models, build the information that actually needs to be channeled to the vehicle in the right way at the right time in order for it to be responding. And that is now available. So for instance, our provider is Traffic Technology Services, and this is what they do for us in the cloud. But I believe that for any DSRC related application as well, you will need that level of intelligence in the middle as well.
There's another partner. So you mentioned infrastructure companies, and I've spoken to many of them, and they're completely frustrated, as you say. They don't know who to talk to at the car companies, and I'm not sure if the car companies are ready to talk to them. But what about the cities? So I think the cities are looking at a scenario where they have to look at their transportation resources as kind of like real estate. So if you have a city, you plan out the real estate. That's going to be commercial, that's going to be mixed use, that's going to be residential, that's going to be a, I don't know, nuclear waste dump, whatever it is. They have to start looking at transportation in the same way, and suddenly they have a bunch of different assets they can play with, public transportation, car sharing, ride hailing, and then controlling access to the city, like London and Stockholm have done. And they're being forced into these kinds of decisions because we have an intractable traffic problem.
Right.
Detroit's a good example. Virtually no public transportation coming into Detroit. So the cities aren't prepared quite yet to take on that task, but they desperately realize they have a problem. DSRC is a potential solution, but I think what they're really interested in, like Tina Quigley, who I know you know very well in Las Vegas, I couldn't think of a more enthusiastic transportation executive in the country, is interested in speed to market.
Yeah.
So you gave her a quick solution to deliver into the car over the cellular modem in the car. That's what people are interested in today, solving problems right away.
Exactly, absolutely. And the fact that the DSRC is here today actually speaks exactly to that speed argument. And the other thing that's really super important is to make sure that we definitely have a strong partnership between companies, different types of companies, right? I mean, no question, this whole idea around business models and disruption, how are companies and cities going to work together to really make money here? There's a lot of different things. Ride sharing is one, driver assistance is another, traffic light, traffic efficiency, truck platooning. There's a variety of ways that definitely, as we all work together in the partnership here, we can
since
make
we're
money.
talking about V2X here, right? So, I mean, I think we somehow make this connection between V2X and immediately jump to DSRC. And I think what the panel is telling you is that's not the case. That's one solution for a large set of technologies and services that need to come together. One interesting area that we're involved in is in the city of Somerville in Massachusetts. We're actually working with the city there to develop an autonomous parking pilot. And now this is now taking self-driving technology in the car and connecting that to the city's parking infrastructure so that you can have these cars that can go off and park in allocated parking spaces that may be in parts of the city that are less utilized but now can be utilized for parking. And because they're all autonomous, you probably only need about 40% of the space of a normal parking lot because you don't need pedestrian walking spaces, you don't need stairs in order to get that all congested. That helps in removing the congestion from the city as well as improving city planning in a big way. So I think that you have to look at this world as not just we came up with a standard 20 years ago and why hasn't it been implemented yet. It's like the world has been doing a lot of things along the way. And what's going to happen is going to be a combination of all of these things coming together and the most efficient way in which you can make the offering available to the customer.
You hit it on the head. From an end user, and then public transportation agency standpoint, we are interested in the end result. We're interested in the application. We're interested in preventing crashes, more efficient traffic flow, whether it's urban or freeway, getting road weather information out there. Really, the means of getting that, really doesn't matter to us. Give us the most efficient way to do it. Maybe it's DSRC, maybe it's cellular, maybe it's combination, maybe it's satellite, maybe it's something else that we don't even know of yet. Right. That really doesn't matter to us as a public agency. We want the benefits of the application. So you're right, the V2X is really, we're focused on the end result, not necessarily the communication.
But I think for federal regulators, they're looking at 100 people or more being killed every day and the toll rising based on statistics for the first half, which drove, I think, the decision right at the very end of the Obama administration. We need to do something. This is the only arrow we have in our quiver. We're gonna string it up and fire this arrow. And the information that I have is that the incoming Secretary Elaine Chao is 100% supportive of DSRC. Unfortunately, the process, nevertheless, is still going to take time to come to market. But meanwhile, the US military is demanding this technology because they have equipment they need to move all over the country, and they want to start using platooning immediately. So they have an immediate application. Again, commercial vehicle segment.
Makes more sense.
I think through the platooning, through the V2X applications have already been demonstrated that they're fairly mature. It's just getting out there into the marketplace and through vehicle penetration. I think it's there. I don't think there's that much left in the development site part of things. I'm not an application developer or DSRC radio guy, so I can't really say that 100% level of confidence, but the maturity is there, and it's just a matter of getting out and making sure you've got the end users, the infrastructure people, the end users of cities, states, and the application developers and the vehicle manufacturers all going on the same path. And we will, hopefully, that's why we're interested, we want to get that traffic fatality curve down to less than 1,000 people that are dying on the roads every year in Michigan.
Absolutely.
We got to get that down, and it's coming, it's there. It's encouraging to hear that there's still, at least for the next 4 years, there's still support for that going forward, and I think we're encouraged
It's the
by
benefit of living right outside Washington, D.C.,
Yep.
as Palm does. But are you going to ask us about cellular V2V?
So I'm actually going to, I was going to take a step back. We've been talking around this a lot, but we haven't actually delved into the actual discussion of cellular / 5G / LTE versus this DSRC standard we've been talking about. So let's take a minute, let's redefine these two things, and then let's talk about let's compare and contrast them a little bit, because I think we should do that. So let's talk DSRC first. That is what we've been talking about. That's the standard that's been coming around for 20 years now. Wi-Fi based. Patrick, do you want to iterate through some of the advantages of this direct point-to-point DSRC standard?
Sure. So if you take a step back and you look at the original intent of the standard, I mean, 20 years ago it was definitely recognized that there needed to be some kind of standard developed and applied to cars that would provide dedicated, short-range, low-latency wireless communications. And what the standards group decided to do was to branch, and this is called 802.11p. And what the standards group decided to do was to use 802.11 as a basis, because 802.11 is a great standard that provides a really good framework for this. But the downside of standard 802.11 is it doesn't provide guarantees for latency or for bandwidth. So if you want to have real-time communication, short range between cars, you had to do something. And so therefore a new standard was needed, and that was the genesis of the 802.11p.
Okay, and now, so the other alternative would be to piggyback on existing cellular networks effectively that are built up around the country already, largely commercially run. Roger, what's the advantage of going to a cellular-based system, a solution to connect one car to another, rather than a direct point-to-point communication?
So the point of using cellular is it's already going into a lot of cars today. LTE isn't just one protocol, it's advancing and developing, so it's expected that release 14, LTE 4, which is more or less 4.5G, will have a direct device-to-device communication, which is not very well understood by a lot of people I talk to in the industry. That, with the exception of these fine gentlemen, there is a new air interface that allows for direct communication that doesn't have to go to the tower, okay? And so at equivalent or less latency, millisecond latency, and but it will take some time, for that to percolate into the market, and it obviously takes longer to get into cars. So I would project that V2V, that cellular V2V capability technology would probably arrive under an ideal scenario, giving DSRC the benefit of the doubt, around 2021. So in essence, that capability will arrive simultaneously in the market. Palm has alluded to the fact actually that there's an opportunity for cooperation and collaboration between the two technologies. Cellular is very likely going to be needed for the credential revocation list, and also there are some applications like the traffic signal timing that could take advantage of both DSRC and cellular signals. But the point is, again, to Palm's earlier point, there's a business model for cellular, okay? We're finding ways to create direct, like selling Wi-Fi data, or indirect business models around that vehicle connection, which would involve data collection, okay? And of course, security and privacy concerns, et cetera, et cetera. But that is the other revolution that's happening, that data collection to take better care of the car, better care of the customer, mitigate distraction, prevent crashes and collisions, and create a more enduring relationship with the vehicle, a full product lifecycle engagement with the car. So the business model is there for cellular, and we're still kind of proving it out. Some car makers are still, I don't want to know, in that I don't want to know phase, but that's falling down. They realize they can't be in denial. And with the 100 million Takata recalls and the amount of software code going into cars, you need to be connected to cars to do the software updates, to find those customers. So the business model is very robust for cellular.
Right. As you mentioned, there are commercial incentives. You can sell services like the ability to start your car remotely and other things like that that are enabled by having a modem in the car. And so we're seeing more and more manufacturers, and Palm, of course, being on the kind of the cutting edge of having in-car communications or vehicle-to-vehicle communications like this, you don't really have a choice because ultimately DSRC isn't really deployed anywhere else. But those modems are already in the car providing data for things like Google Maps and other things.
Yeah, so it's an interesting time we're in right now because it may seem like the conversation needs to shift immediately towards B2C because Roger was alluding to the 5G standard, which is supposed to come in the 2021 timeframe, and everything that we hear indicates that it will be very comparable, if not even better in many cases, to what the DSRC performance can be. Of course, yet to be proven widely and yet to be confirmed. But if that's the case, then you've got one check mark on the list of things that you need.
Sure.
I think there's a couple of other things. There's from a quality of service of the network standpoint, having a cellular network provider that is incentivized to keep that up and running is obviously a good thing. So if there's a commercial model that already exists to keep that alive, then that's a second thing that sort of works in the favor of cellular. The part that is still, in my mind, still a bit of a question mark and probably will be clarified over time is, what about the fact that you have active safety and non-safety related applications working on the same spectrum? Does that pose any kind of a hazard in terms of what you need? Because DSRC was kind of designed as a dedicated channel to only allow communication between vehicle to vehicle. Do you now, if you allow other types of communication to happen in that same spectrum, enter that kind of an issue? And I think we hear both sides, and we hear that the industry is quickly understanding how we might be able to resolve some of those things. The bigger one that I still don't see a good solution for is the cellular industry has a tendency to migrate technologies every 10 to 15 years. And so if every 10 to 15 years a whole bunch of cars becomes incapable of communicating on these technologies or need to be upgraded, that's a cost factor that needs to be considered ahead of time, or you need to find a way to obsolete those cars. Or if we really think in a more progressive way, I think what we need is some baseline standard that needs to be maintained even if a technology migrates from one to the other, so that even older cars will have the same active safety benefits. And I think as we look at these 4 questions, 2 of them clearly point towards cellular. One of them a little bit is moving towards, but is still on the DSRC camp. The last one right now is where DSRC is strongest, which is it is the one confirmed technology that will stay stagnant, or at least that's the conception.
And that's for 20
the
years.
One that, the one that goes completely against DSRC is that the DSRC standard is 20 years old. In 20 years, how standards for network technologies are written have evolved quite a bit. Efficiencies, all of that has changed, and so it is an older protocol. It's like talking to your grandma over a cup of tea versus, IMing or Snapchatting, and so that difference also needs to be kept in mind.
So quality service is a big issue. You can't have your Netflix stream interrupting your communication from an oncoming car. Security is obviously a big issue too, and planned obsolescence is definitely a big issue. From a DOT standpoint, do you have any skin in the game here? Is there a difference or an opinion as far as which is the preferred implementation, or just getting it to market as quick as possible?
It's probably the biggest when it comes to the cellular standpoint. Great points for both before and or for and don't know yet about cellular. The big thing from us, from the public standpoint, is we have to make sure that the cellular applications or what have you aren't subscription based. We don't want to have safety applications that we're behind, and again, that might be my ignorance as to what the standards are going to be, but we have to make sure that what we're doing isn't only available to those that pay for a service or on those ends. And again, we don't have enough familiarity with dealing with those standards yet, or those applications yet to see how that's going to work. That's a big thing. The point you brought up about the spectrum sharing, about everything we heard about DSRC and spectrum sharing, the same hesitation about going down that route and relying on a spectrum that could be shared for safety and non-safety. That holds true for the cellular standpoint too. If it's something that's going to be shared for data streams that are safety related, non-safety related, that causes concern for us too if there's going to be an intermingling. But those are probably the 2 big ones right there.
Yeah, exactly. And I think the key point that you're hearing from the panel here is that it really is driven by the application. And also by the availability of and the maturity of the different solutions. Our view is that absolutely there's complementary applications, there's complementary adoption capabilities, and from my perspective as a driver or passenger in these things, I mean, bring it on. Obviously I would like more technology in the car to keep us safe and to keep us secure as drivers. As a technology provider, one of the technology leaders in the industry, Yeah, absolutely. Let's use what we have and prime the pump and get the wheels turning in terms of business models, adoption, smart cities, and so forth.
Matt, it's interesting. Sorry, go ahead, Roger.
It's funny what Matt said about not having to pay a subscription. So I was on a panel a month or two ago in Tokyo where there was a Telenor connection executive. They're a European wireless carrier, and they were talking about a subscription model for automated driving. And I said, wait a minute, I can't even always count on getting a connection to make a phone call. How am I going to have dependence for automated driving on a wireless connection to the cellular network? But on a more serious note, I was surprised you didn't bring up a challenge for the DSRC implementation, which is we haven't figured out what to do about the secure credential management system. Who's going to provide that, and how is that exactly going to work? That's a big question.
Yeah, I mean, you're right. I mean, we haven't quite figured out business models either. Like Matt brought up, the investment is not really clear where it's going to come from. And maybe what we're talking about is that there are certain areas where DSRC will be viable as a technology that can be financed, and then there's other areas where we have to rely on cellular, and the combination of the two is really where we need to evolve to. Or maybe there's a smarter way of doing things, and cars connecting to cars eliminated the need to put anything in infrastructure. How far can we go with that idea? Especially if you now say the cars are also autonomous, so that they're not just dependent on the communication between the cars, but the sensor array is becoming a lot smarter. There's artificial intelligence being built in the cars that is learning the behavior trends, and over time can learn how to react in certain situations. I think all of these factors are going to influence the safety record that we have in this country to help that come down. And I think that the best thing we can do is, as leaders within our respective fields here, is to watch for what can be done today and how can we make it easier to implement. And I'll be a little selfish here. Our traffic light information service, we think, has a lot of benefits, and we'd like to roll it out a lot faster than we're seeing we are able to, and that's primarily because of the state of evolution of different cities. Some cities are up there, ready to go. There's other cities that need a little bit more time. And I think that you can do something like that with a comfort and convenience feature like traffic light information, but if it's a safety-related feature, you don't want to have a part of the population that's able to access that and not a different part. So how do you actually make these things move a lot faster? And I think what we're going to have to do is let the comfort and convenience features allow the spread of the infrastructure development to happen, and then we'll switch on the safety benefits.
That might be the way to get it out there. I mean, no one's going to buy a widget because it's got the safety capabilities to it, so you got the convenience factor, technology grow, and then build in the safety from there. I think that's...
Consumers want safety. In all of our surveys, all over the world.
That's good to hear. That's fantastic.
But I did want to add an interesting vision, which was shared with me by an Ericsson executive also a few months ago, which was the idea of virtual guardrails. Imagine if we can figure this thing out, you don't even need guardrails on the highway anymore. I mean, I know it's a little scary thought, but if we can do it right, if we can get the coverage that we need, and maybe it requires both DSRC and cellular, I don't know, but and then get rid of all the signs. Maybe we don't even need street lights anymore.
Absolutely.
Street lights, traffic lights, signs, parking lots.
We cannot wait. Narrower, more narrow lanes, less footprint roadways. So I think what we can do with our budget, if we get rid of signs and traffic signals, that'd be huge. No one's going to hit a pothole in Michigan then if we get to that point. So
we've been talking around autonomy, and obviously I think a lot of people connect V2X and autonomy and almost bring them together in their minds, but we're seeing a lot of development, of course, in the world of autonomy, despite the fact that none of this V2X stuff has really come to fruition yet. So the question is, do we actually need V2X communications for...
We've got one in Las Vegas that's working.
That's true. Oh, true. That's true. There are some out there.
Yeah.
Do we need V2X before we can get to autonomy, or can autonomous cars move on and steam ahead forward even if we don't bring this to market?
Yeah, so I want to go back and touch on that point around safety. Absolutely, we as consumers or passengers or drivers absolutely expect that when we get into an autonomous vehicle, it keeps us safe, it keeps us secure. Conversely, any type of possible risk has the risk to absolutely delay or disrupt the adoption. So therefore, it's incumbent upon us as providers and leaders to ensure that all of these types of technologies that are needed for autonomous driving are actually in place. The example I gave before of being able to see around corners, even with other obstructions, maybe around other vehicles and so forth, that's provided real time with V2V. That's an important essential element of cars today. Now, as we move forward, are there going to be more technologies and more sophisticated aspects and more business models and things developing? Absolutely. But I think the safety security aspect for autonomous driving is a really important aspect of it.
I would say that as long as we're going to have mixed fleets in the roadway, which for the foreseeable future is probably within most of our lifetimes, that's what we're going to see, autonomous vehicles with the dumb vehicles, so to speak. I think V2X is going to be critical. You look at what Audi's doing with the traffic signal systems. Yes, it's not DSRC, but it's really still V2I. You're still getting infrastructure information, broadcasting it into vehicles. You're still getting signal information as another input into an AV. So I think as long as you have that, the mixed fleets, that ability to communicate with other vehicles that aren't quite as smart or have the sensor capabilities, and ability to have the infrastructure assist in making those not quite as smart vehicles smart and behave better. I think there's still a market for that, and I would imagine that's 30 years minimum.
I think the autonomous vehicle roadmap is pretty clear. That's going to happen for sure.
Yeah.
And then I think the connectivity part of it adds to it.
I think we are out of time, unfortunately. I feel like we could probably talk about this all afternoon, but unfortunately we do have to close things down now. Thank you, Palm, Patrick, Roger, and Matt for taking the time out here in Detroit to talk about V2X communications and V2I and V2E and V2 everything.